Hello everybody, so we're doing our first kind of lesson about quadratics here, and this is about graphing quadratic functions in vertex form and intercept form. So quadratics can come in a lot of different shapes and sizes. You know, they're U-shaped, we talked about that in the last video. They can be big U's, skinny U's, upside down U's, all over the place. So the equations can look a lot different. So there's kind of three big ways that equations can come: vertex form, intercept form, and standard form. So we're talking about two of those today. The definitions, some of the vocab that we'll see today. First of all, vertex. Vertex is either the top or the bottom of a U-shaped graph. So a vertex can be a minimum. That's if the graph's pointing up. I'll get to this in a minute, but on the next slide, board, you'll see this too. But the minimum is the bottom of the graph, or it's a maximum, and that's the top of the graph, depending on if the U is turned upside down or right side up, pointing up or down. So that's the vertex. That's the most important point on the U for sure. There's also intercepts. This is where the graph, the U shape, crosses the x-axis. These will be really important when we start solving for quadratics. That's really what we're solving for. And the last vocab word is axis of symmetry. This is the line in the middle of the U, usually a dashed line, and then this is kind of where the mirror point is of the U. So the U, U is a symmetrical letter if you draw without the tail. So we're drawing the middle of the graph when we do the axis of symmetry. So first up, we're going to talk about vertex form. Vertex form looks like this. It got a little marked up here. But vertex form has a letter in the front, parentheses, x minus a number, parentheses squared, plus k. So this should look really familiar to people who have done absolute value before. If you've ever done an absolute value graph, it looks extremely similar to this, except for these are bars and there's no squared. Otherwise, we're doing a lot of the same stuff. What's nice about the vertex form is that it tells you a lot of information right away. So the A tells us if it's skinny or wide. If your A number, that number in front of the parentheses, is bigger than 1, then it'll be a very skinny U. If your A is smaller than 1, it'll be a really wide U. A also tells you if it's up or down. If A is negative, the graph faces up. If A is down, the graph faces down. The U arrows point down. And then these other two numbers, H and K, those will be numbers. That tells you where your vertex is. Remember, your vertex is your most important point. That tells you the maximum or the minimum of the graph. So here's our first example. It says sketch a graph of y equals 1/2 x plus 1 squared minus 2. So I circled the 1/2 in red because that's our A. The 1/2 tells us, because 1/2 is positive, it's going to be a minimum. And also, because 1/2 is less than 1, it's a number smaller than 1, it's going to be a wider graph than the original function would be. In here, the blue lines, that tells us our vertex, so you do the opposite inside the parentheses, just like with absolute values. X plus 1, we do the opposite, we get x minus 1. The one on the outside stays the same. Minus 2 out here turns into a negative 2 over here. And then the axis of symmetry is just the same as your x part of your vertex. So those two are the same, so that's where your axis of symmetry is. So looking at the graph, so our final answer is just the graph. We plot our vertex right here. That's -1, -2. Then we use, just to get a sketch, again this is not a perfect graph, but just to get a sketch, we use the 1/2 as an idea of where our first points will be. So we go up 1 over 2, up 1 over 2. And that doesn't continue forever, but it does continue for the first few points, and then we can just draw in our U. So we have our axis of symmetry down the middle. We have our vertex we got from these two numbers. We get an idea of what the U will look like from the A. It's a minimum and wide. And we use that A to kind of graph our first couple points, one on each side of the vertex. So here's the next example. It's a very similar, sketch a graph of this function. So we have -1/4 x plus 2 squared plus 5. So again, we look at our first number, the A, the one circled in red. That is a negative number, so we know our graph's going to be a maximum. Also, 1/4, we ignore the negative. 1/4 is smaller than 1, so it's going to be a wide graph. And you can see that already in the graph that I have over here. So that's the red, that's the A. Again, the A tells us if it's skinny or wide and if it's up or down, a maximum or minimum. And then the other two numbers tell us where the vertex is. So we do the opposite of +2, that's a -2. We do a +5, that stays the same here. We take the x value, and that's our axis of symmetry. These are the four really important things about our graph. So first of all, we graph our vertex. So we graph it right there. -2, 5 is right there, so that's our vertex. Then we can draw in our axis of symmetry just straight through our vertex. And then our last thing is we use our A value to plot a couple points. So we go down 1 over 4, down 1 over 4. Then we draw in our U shape. We know it's U-shaped because it has a squared. So that's vertex form. The other one we were going to talk about today is called intercept form. Intercept form looks a little bit different. It's got two separate parentheses as opposed to two together. And what intercept form does is it tells us where the graph hits the x-axis. So it'll be a little bit more complicated. What we do first is we graph our opposite P and opposite Q. So let's say this was x minus 1, we would graph a positive 1. And we'll see that on the other examples. But we graph these 2 points. Then we find the average of those two, the middle. So just on this example, I have -2 and +4. The number in the middle of those is 1. So that's where our axis of symmetry is going to be. That's where our vertex x value is going to be. Then we use the number we get in the middle and we put it into our equation to get our y value. So we plot the intercepts, we find the middle for where our vertex will be, and then we put that x middle into the equation to find our y value. So we'll do a couple examples like this so you can see what it looks like. So example 3 says sketch a graph of y equals 2, x plus 3, x minus 1. So what we want to do is we want to do the opposite of P. So instead of graphing a +3, this is a big mistake students make, instead of graphing +3 I graph -3. Right here, I can't really see blue, but it's there. And then instead of x minus 1 I graphed +1. There's the green dot right there. So we graph those first. Next we can look at, next we want to put the find the middle of these two. So we want to find the axis of symmetry. So we add -3 and +1. Those are our plots, the points we plotted. And we find the average of those and we end up getting -1. -1 is our x value for our vertex and it's our axis of symmetry. The last step is we put -1 into our equation. That's what I did here in blue. And we would get out -8. -8 is our y value for a vertex. So I plotted the vertex down here at -1, -8. Vertex form is a little bit more complicated. I mean, just kind of the way it is, but it's still, still not too bad, hopefully. This 2 is still our A, even though it's a different form of the graph. That's still our A. That still tells us it's a minimum because it's bigger than 1, because it's a positive number, and it's skinny because it's greater than 1. So you notice that this graph looks quite a bit skinnier than the other two graphs that we did in examples before. Our last example is very similar to that one. Sketch the graph of f of x equals negative parentheses x plus 1 and then x minus 5. So again, opposite, so we graphed -1, there's my blue dot. Again, opposite, we graphed +5. So that's first, graph those points. Second, I find the average of those points here. I did that in green. That is our x value for our vertex and our x value for our axis of symmetry. So I drew the axis of symmetry down the middle there. Once we have that, we put 2 into our equation and we get out 9. 9 is our y value, so I graph 2, 9. Again, the number in front, the negative, tells us what the graph looks like. It's a negative number, so it's going to be a maximum, and it's a 1, so it's actually going to be the same as a parent function. It won't be skinnier or wider, and it will just be a normal width. So that is vertex and intercept form. In the next video, I'll do standard form, which is similar to this, but just a little bit different. The equations look a little bit different. So.